Section 8.2. We are going to do the operations now. Addition and subtraction of radical expressions. All right, so this is super easy. If there is condition, if we know how to simplify a radical expression, to add and to subtract radical expressions are super easy if we know how to simplify them. And let me start with, so how do we add or subtract the radical expressions? It's very similar to when we combining or simplifying the polynomials. We'll see we have like terms. What are like terms? If the terms have the same variable, have the same exponents, they're called like terms. And for the radical expression, they're also like radical expressions. They're called like radical expressions. What are like radical expressions? When the radicands are the same. For example, radical 3, that is one radical expression. And if I have 5 radical 3, so those two, they are called like radical expressions. Why? Because I only care, I don't care anything else. I only care what is within the symbol. I see 3 here, I see 3 here. So those two terms, they are called like terms. If I'm adding those two radical expressions, I'm going to just combine their coefficient and then keep the radical part. What is the coefficient of radical 3? That's 1. So 1 times radical 3 plus 5 times radical 3, it equals 1 plus 5 times radical 3, which is 6 radical 3. See, to add the radical expressions, if they're like radical expression, we just combine them, combine the coefficient. Subtraction, same thing. If I have radical 3 minus 5 radical 3, what do? That means 1 minus 5 times radical 3. That's subtraction. 1 minus 5 equals negative 4. So negative 4 times what? Radical 3. It's very, very similar to, so x plus 5x equals 6x, or x minus 5x equals negative 4x. Same idea as combining like terms. When we are doing the addition or subtraction of radical expressions, we just combine like radical expressions. Okay, but things are not always this simple. Sometimes we might have a problem like this. Okay, watch me. If I give you problems here, so hey, please do the calculation. Radical 3 plus radical 12. When you see this problem, you'll see, well, those two terms, they're not like because they do not have same radicands. I cannot do anything with that. The answer is wrong. Why? Because when we are doing the addition or subtraction, before we start to do those two operations, we have to make sure every term is completely simplified. So can we simplify radical 3? Oh, see, 3 is the only factor. We can now do simplify. It is simplified already. And then when we see radical 12, I copy this problem and now go back to section 8.1. If I ask you, can you simplify radical 12? What do we do with that? We factor 12 as 2 times 2, 2 squared, times 3. So 12 equals 4 times 3. You know 4 is 2 squared, it's perfect square number. So can we simplify this expression? Of course. 2 can be moved out, and we'll have 2 times radical 3. This is what we did in section 8.1. Now when we are working on the problem in section 8.2, we just apply what we just did. Radical 12 can be simplified as 2 radical 3. They are equivalent. Now when we look at this problem, we'll say, are those two terms like or not? Of course, they are like. I see 3 here, I see 3 here. We only check the radicand. We only check the expression within the symbol. So there is 2 here. Does not matter. The like terms just mean they have the same radicand. Okay, so can we combine those two? Of course. 1 plus 2, that's 3. It equals 3 radical 3. See, given this problem, we end up with this answer here. So don't be tricked by the original problem. Not all the problem, they're given every term as a simplified one. So if we want to do operation add or subtract, we have to simplify the radical expression first by ourselves and then combine like terms, like radical expression. Okay, so having this, we just need to do a few problems. All right, so let me grab this practice sheet. So we are asked to add those two problems. Because first, let's see. For those two radical expressions, are we able to simplify each one of them? The first one, radical, so equals radical 2w. 2 is 2 to the first. W is w to the first. Nothing can be moved out. Plus 5 radical 2w. And again, we cannot do anything with that. Those two are simplified already. Then we check, are they like or not? They are like 2w, 2w. So therefore, we combine the coefficient. Don't forget, we have a number 1 as a coefficient. 1 plus 5, 6. Square root of 2w. Final answer. So this is the simplest case. For the other one here. And we have w times radical 45. When we say 45, I hope you know 45 equals 9 times 5. Or you write this as 3 times 3 times 5. It's the same thing. And minus square root of 5w squared. So before I start to do the subtraction, I simplify each one if it is possible. So can I simplify this one? So 9 can be moved out. I will have a 3. So write 3 in front of w. 3w. And I have a 5 left inside of the radical symbol. Minus, for this one, 5 stays. W can be moved out as w, radical 5. Now we see, are they like terms? Yes, they are like terms. We'll keep the radical part, combine the coefficient. What are the coefficients? 3w minus w, that's the coefficient, followed by radical 5. And can we stop here? No, because we can continue to simplify the coefficient. 3w minus w equals 2w, radical 5. That will be the final answer. See, no matter we are doing the addition or subtraction, simplify each term completely, then combine the like radical expression. So there are those two examples. Let me grab if I see more. Okay, I'd like to do a few more problems with you. Let's do this one. Radical 72 minus radical 18. Okay, a common mistake. Do not just combine so that this equal to, I hope I do not mislead you today. Okay, but this is a very common mistake. I have seen many students, they subtract that one, that means I'm going to subtract 72 and 18, and then that equals 54, and then I simplify at this like 3 radical 6. This is completely wrong. Okay, we can never combine the radicand. We can only combine the like radical term when they have the same radicand. So for this one, what the right way? 72. So if you notice, okay, for me, I notice 72 equals 2 times 36. 36 is perfect square number. If you do not recognize this, take your time. So pretend that I'm new to this topic here. I know, I just take my time. 72, do the factorization. Use the factor tree equals 8 times 9. 8, 9 equals 72. And what is 8? 8 equals 2 times 4. This 2 is prime, circle 8. 4 can continue to factor it as 2 times 2. And 9 equals 3 times 3. So when I do the factorization, I see 72 equals 2 to the third times 3 squared. So 2 times 2 times 2, 2 to the third. 3 times 3, 3 squared. Minus, what is 18? Same thing, 18 equals 2 times 9. 9 equals 3 times 3. Okay, so 2, 3, 3, that is the end prime numbers. So 18 equals 2 times 3 times 3, 3 squared. Don't touch the subtraction part yet. Work on each term, then simplify. So as we said before, 2 to the third. We can write this as 2 squared times 2. So leave 2 inside. I have 2 squared. That can be moved out. I have 2 out. The 3 can be moved out as well. So I still have a 2 left. And for the second one, there's 2 stays, but 3 can be moved out. I have 3 radical 2. Simplify this as 6 radical 2 minus 3 radical 2. And what does this equal to? 3 radical 2. Final answer. So take your time, be patient, and the more you practice, the faster you will be in the future. But at the beginning, like what I did here, use the factor trees and break this down to a complete factorization and then move as many factors as possible. Okay. And one more example. Okay, let's look for the last one. Okay, so first one, what can I simplify? So this x stays outside. I know 81 equals 9 squared can be moved out. I have times 9. And this x stays. And this y to the third can be seen as y squared times y. I leave one y inside. I have another y out. And so this is the first one. And for the second one here, I have y here. And then 64 can be moved out. I have 8 there. X to the 5 can be written as x to the 4th. See, I can't be skipping steps now. X to the 5th means x to the 4th times x. I leave one x here. X to the 4th, move out, turns into x squared. And this y stays. Then just resort, okay, the factors, and x times 9 times y, we write this as the alphabetical order, but number always comes first. That equals non-xy, radical xy, minus, so I have 8xy is 8x squared y, follow the alphabetical order, radical xy. Then I ask myself, are those two like terms? The answer is yes, because they have the same radicand. Then we just need to what? Combine the coefficient. If this, no matter is addition or subtraction, same thing. Just combine the coefficient. Non-xy minus 8x squared y, parenthesis, followed by radical xy. Final answer. Okay, so this is the last example I want to share with you. When you do the problems on my open math, if you need help, don't be shy to reach out to me. You can just send me a message, Professor, I need help on number 10. And I can either send you my solution or I can schedule a very short meeting with you and to work the problem out together. Okay, I will stop recording.